Technology. Supposed to be good at this. Okay. Yeah, thanks so much, everybody, for having me here. It's my first time in Kiev, first time in Ukraine, so I'm excited to be here and excited to be talking about Crystal. And Crystal is a new programming language, relatively new, much newer than Ruby. Ruby is about 20 years old now. Crystal is just 2 years old. And you know, I think it's a bit odd to talk about a language that isn't Ruby at a Ruby conference, but I think that's actually, Crystal is very similar to Ruby in a lot of ways, and I think a lot of the things that maybe you like about Ruby, you'll find in Crystal and find that you like about Crystal, and a lot of the things that you maybe don't like about Ruby, some of the things in Bojadar's talk this morning, for example, the bad parts of Ruby aren't in Crystal. It's a nice modern language, and the way I like to think about it is if Ruby was invented today, in 2015, I think it would look something like Crystal, right? If we took the last 20 years that Ruby's existed and incorporated all of the advances that we've made in computer science and understanding programming and technology, yeah, that's good. Okay. Seems to have fixed itself. Okay, so somebody asked me on Twitter for sort of the TLDR 140 character version of this talk. So if any of you need to leave and you're going to miss it, this is sort of my argument for Crystal in 140 characters. So you already know the syntax because the syntax is basically Ruby syntax. The code compiles into. Is there anything I can do about that? Yeah? Good. Okay. So the code compiles into... I know what it is. No, I know what it is. It's too close to my phone. Okay. Technology. Good. Okay. Okay, sorry. My fault, actually. Okay, so the code compiles into an efficient and easy to distribute binary. There's no runtime, right? So what I mean by no runtime is you don't need to install Ruby or install Crystal to install a Crystal program. You can just install the binary. It makes shipping the code very easy. Right, and I think Go is another example of a modern language that's gotten a lot of popularity recently, partially because it's so easy to distribute, right? If you want to install Docker, for example, it's a very popular program written in Go. You just install a single binary and it works. You don't need to install Go first. It doesn't have gem dependencies or Ruby dependency or anything like that. It also has static type checking, so it's a bit safer. This is a feature that doesn't exist in Ruby, but exists in most modern programming languages. And I think it's really nice because it allows you to catch errors earlier. We talk a lot in Ruby about writing tests, and the reason that we write tests in Ruby is because we want to catch errors in the tests before our users experience those errors, right? We don't want the users to catch the bugs, we want the test to catch the bugs. And a static type checker is another way of catching bugs ahead of time, before the user hits them, right? So the program will fail when you start the server, for example, instead of when a user hits the server with a request. And it has macros as well, which is quite a neat feature, different from Ruby, very powerful feature. So, if you're going to have a new language, I think you're really asking a lot from programmers, right? You're asking them to learn a bunch of new things, right? Learn a whole new language, right? If I said, okay, maybe you speak English or you speak Ukrainian, you know, learn Spanish, right? You're asking a lot of someone to do that. It's going to take a lot of their time to do that. And yeah, you have to learn a new syntax. You have to write all this new documentation or read the new documentation. You have to re-implement the standard library. And then one of the things that's great about Ruby, the thing that really made Ruby take off, I think, is this ecosystem, right? All of these gems, right? Thousands and thousands of gems that we use all the time. And yeah, you have to sort of reinvent that from scratch. If you create a new language, you're basically asking people to take the whole ecosystem that they have, the Ruby ecosystem, and throw that away and start over from scratch. So if you're going to introduce a new languages don't come along that often, right? We still all use Ruby. It's been around for 20 years. If you're going to introduce a new language, that's you're really asking a lot for a developer to learn that. And then the last part, of course, is the new community, right? So we're all here at a conference, we're meeting each other, we're trying to learn things. This community doesn't exist for Crystal, it exists for Ruby. And if you want to start a new language, programming language, the programming language isn't just about the compiler for the programming language, it's about the actual community, right? The people. That really makes a difference. So, I'm going to talk about why each of these things for Crystal, either it's a solved problem or it doesn't matter as much as you might think it would. So the new syntax, okay, you're asking people to learn a new syntax, but if you already know Ruby, you know Crystal syntax. Crystal basically takes its syntax from Ruby. And so to learn Crystal, it's a very easy ramp if you're already a Ruby programmer. And if you're not a Ruby programmer, then it's about as easy to learn as Ruby, which I think is quite easy, right? Ruby is quite a friendly language. It's sort of designed to be user-friendly, have a nice syntax, be easy to learn. And Crystal syntax borrows this from Ruby. And yeah, you can use Ruby syntax highlighting in your favorite text editor, right? So all of these programs that we've written to do syntax highlighting, you don't have to rewrite those programs for a new language. You can basically just use the Ruby one and it will mostly work. So, okay, the new syntax doesn't matter. Well, what about documentation, right? Do we have to start over and write documentation from scratch? This is a great tweet. So the founder of the Crystal programming language tweeted at Mats, "Is it okay if we copy some of Ruby's documentation, classes and methods, in Crystal?" And Mats replied, "Yes, I copied it from Perl." Right, so the first Ruby documentation was copied from Perl, and a lot of the Crystal documentation is sort of bootstrapped from Ruby's documentation. And again, you can do that because they share a common syntax. Yeah, and then the final reply, standing on the shoulder of giants. Yeah, great. Okay, documentation, no problem. What about the standard library? Well, it's true that you have to re-implement a standard library, but I think this is actually one of the areas of Ruby that really is showing its age. And Bojdar talked about this morning in his talk. All of the parts of the standard library that need to be, are just not that good, right? Like they haven't been updated in a very long time. Nobody actually uses them. There's a lot of things that are more useful that maybe you wish were in the standard library or are not in the standard library. And there's a bunch of gems that are actually better than the standard library equivalent. So we were just talking about at lunch today. There's ERB built into the standard library, but there's a third-party gem, Erubis, which seems to be better in every way. It's fully compatible, it's faster, but we don't use that. That's not built into the standard library. Another example of that is the OJ gem. It's a gem for parsing JSON. It's faster than the JSON gem that's part of the Ruby standard library, but we're stuck with the standard library version. Let's take a look at what a modern standard library would look like in a language that was invented in the past few years. So it has a spec framework built in. So just like Ruby has test unit and now mini-test built into the standard library, Crystal has a spec library. It's just called spec, and it's very, very similar to RSpec. If you use RSpec, spec will look incredibly familiar. The syntax is almost identical. Well, again, just like Ruby, you have CSV built in, JSON built in, XML, a YAML parser, but there's also a Markdown parser, right? Markdown was something that didn't exist when Ruby was created in the mid-90s, but now Markdown is really popular, right? It's a popular format for writing blog posts, for writing documentation. I think we all use Markdown as sort of a shorthand for writing HTML, and there's all these competing Ruby libraries that do Markdown, but isn't that something that should be built into the standard library in 2015? And in Crystal it is, so I think that's really nice. There's also an HTTP client and server built in. I think this is one of the biggest areas of complaints in Ruby's standard library, specifically the HTTP client, net HTTP. People really don't like the syntax of that. I think the Crystal implementation is really nice. And I'll be giving a demo of the server later. It's a really powerful server, right? So Ruby has WebBrick built into it. That's the server that you get. But it's not really a great multi-threaded web server. It's not something you would deploy into production, hopefully. And Crystal's built-in web server, the one in the standard library, you can safely deploy to production. It's a really nice web server. And I'll run some benchmarks so you can actually see that later on. It also includes WebSockets, right? So again, WebSockets are something that didn't exist. It's a web technology that wasn't around at the time when Crystal was created. Now it exists. It should be part of the standard library. It's not part of the Ruby standard library. It is part of Crystal. OAuth and OAuth 2, right? These are very useful. I think we use these services all the time for doing authentication on the websites that we build, right? Ruby is very popular for building web applications, and OAuth is sort of a core web protocol nowadays. Not in Ruby's standard library, you need a gem for that. In Crystal, batteries included. It just ships with the language. So I think that's great. And it also has a lot of other nice things. So there's a random number generator that's quite powerful and robust. You can calculate the Levenstein distance. So for doing things like spell checking, that can be useful. There's an HTML builder, similar to the HTML and XML builder that Jim Weirich wrote for Ruby that just comes with the language. So I'm going to just cross that off the list because it's basically done, right? It's something, it did have to be re-implemented, but at this point it mostly has. The standard library is there, and I think it's quite nice. What about the ecosystem? Not the standard library, but the sort of gem ecosystem in the Ruby world. Does that exist in Crystal? And this is an area where Crystal is really lacking, and that's part of the reason why I'm giving this talk today. I'm trying to encourage you, the community, to build some of these third-party libraries. So I did this search on GitHub just for language Crystal, no actual text query, and it returned 37 repositories. So that's not very many on GitHub. And it actually shows you just as sort of a shaming in the right-hand side. You know, JavaScript has over 1 million. Crystal has 37. The number one repository when you search for something that's in the Crystal language is Crystal. This is one of my favorite things about Crystal. It's a self-hosted language. So Bojidar, I think, had an example this morning where was it compact? The compact bang method on an array or enumerable? I guess on an array. The compact bang method was implemented in C. So if you wanted to go in and understand that, okay, maybe you can look at the Rubinius code, but sort of our standard implementation, MRI, which we all use, is written in C. And it's quite an, I would say it's not the most readable C I've ever seen. Crystal is written 100% in Crystal. The whole language is self-hosted. So if you want to see how something works and you know Crystal, you don't have to learn a different language. You don't have to learn C to actually get in there and start messing with the language. You can just read the code and make changes to the language. I think that's one of the best features of it. And it's easy to become Crystal famous. The second most popular repository, these are sorted by number of GitHub stars, is one that I wrote in about a weekend. So yeah, I wrote it, when I took this screenshot, it was less than a month ago. I had gone from being a repository that didn't exist to the second most popular only to the language itself, and with just 5 stars. So with 5 stars, you can have the second most popular repository in the language. Yeah, and just to sort of hammer it home, yeah, JavaScript has 1 million, right? So and since I've made this slide, there's actually been every week there's new third-party libraries that are, if you join the Crystal mailing list, people are posting and announcing that they're adding these things. So just, I think about 2 or 3 weeks ago, somebody wrote a MongoDB driver for Crystal. There's a Redis driver now. There's adapters for Postgres and MySQL and all of the common databases. But these are being slowly added by people just like you and me, right? So it's a very, very early stages of the community, but these things are just starting to be implemented. And so yeah, you can be Crystal famous with 5 stars. Just Just get 6 of your friends to star something and you'll be more popular than me. Okay, so I would, instead of, like the ecosystem, okay, it definitely needs work, but I would say it's a real opportunity, right? You can be one of the sort of pioneers in this new language. So don't think about it as a drawback, think about it as an opportunity. So the community is the last one. And the Ruby community, I think, I have the same slide. I made these slides before I saw Vojdar's talk, but he had the same slide. We have this concept that Mats is nice and so we are nice, right? And I think that really drives the community, right? This isn't a community that's like the Java community where it's backed by a big corporation that did all the development of the language, and it was developed by this sort of big team of people who were getting paid for it. Ruby was developed out of love by one person who thought he could make a better programming language, had an idea for how to do that, did it, released it to the world as an open source project. It's not like there's one conference, Java 1, that happens, with 5,000 people that show up in San Francisco. Ruby has these little self-organized conferences that are, again, sort of driven by people's passion because they love the language. They want to meet other people who are doing Ruby in their little area. So I think that's my favorite thing about the Ruby community. And I think Crystal has, I just want to talk about this concept of Minneswan. It's like it's a popular concept. It has a Wikipedia page. There's a whole Wikipedia page on Minneswan and sort of what that means. Someone made stickers. I actually have one on my laptop of Mats. And you can wear it as a t-shirt. You can make it your desktop wallpaper. Right, there's all these things. So Crystal, I think also, it has some really nice founders. The people who created it are also really nice. And I think that's really important. So the main creator of the language is Ari. This is his Twitter and GitHub avatar. This is what he actually looks like. And he, the sort of co-creator of the language is Juan. This is his avatar. This is what he looks like. And they're really nice. They live in Buenos Aires. They work for this company called Manas Tech. And the language is about 2 years old. And they're nice. Ruby is nice, Mats is nice, and Crystal is nice. Ari and Juan are nice. And this is like the evidence that I have for the fact that they're nice. So I was one of the early users of the language, and I opened up some issues. And this particular issue was that if you send something to putS, an object to putS, I would have expected that to sort of implicitly call the toS method as it does in Ruby. I opened this as an issue, and it was closed within something like 10 minutes. It was unbelievably fast how responsive they were to that. So you can see this is another one. Cannot sleep for a fraction of a second. So if you said sleep 1, it works. But if you say sleep 0.5, that doesn't do anything. And again, it was fixed. I wish I had the date stamps on here, but it was like literally fixed within 10 minutes. They're incredibly responsive and incredibly nice about it. And even when I open issues that are they don't agree with. So this was a feature I proposed. In Ruby, there's no difference between a single character and a string of characters. But in Crystal, you actually have this distinction. There's a single character and a string, 2 separate things. And I expected that you would be able to concatenate a string of characters with a character. So in my example, I have a string foo, and I want to concatenate the character D to make food. And that wasn't a feature. And at first they rejected it. They said, actually, this is intentional because strings and characters are 2 different data types. And so you can't concatenate 2 different data types the same way you can't concatenate strings and integers. This is a feature, not a bug. But we went back and forth on GitHub, and they thought about it. They basically decided they were like open to my reasoning, and I actually convinced them that this was a good idea and that concatenating a string with a character actually does make sense, and it's different from concatenating a string with an integer, for example. So they just seem like very reasonable people, and you can, like, if you make a good case for how the language could be better, they will actually make that change. This is a really big change to the language, but the language is so sort of young, so early in its development, that you can actually have an influence on the language at this level just by opening an issue on GitHub. So I think that's really nice. So yeah, like to sort of answer the question, and in summary, like why do we need yet another language? We already have so many languages. So it's a high-level language. It has Ruby syntax. It's garbage collected, so you don't need to do manual memory management. It's compiled using LLVM. So again, you get these binaries that are really easy to ship, to distribute. It's statically typed. So, and it's not just statically typed. Maybe, you know, in university you learned about Java, which is statically typed. Ruby isn't statically typed in the way that Java is. It has a really nice type inference system. So even though it's statically typed, you almost never actually have to put in the types. It can infer them almost all the time. And it has this thing called union types, where it will basically create new types on the fly. So, for example, you can have an array, and that can be an array of integers, or it can be an array of strings, but you can also have an array of the union type integer string, which means it's an array that can contain integers and strings, but nothing else. So, and you can have as many of those unions as you want to sort of build up these complex types. And these things work together, so it can actually infer a union type if you have something that could be, for example, a string or a nil. Yeah, I'll show a demo of that later. It has a really nice macro system, which is a really powerful feature. It has method overloading. So let me actually go back to the macro system. A lot of people like Ruby because it's really dynamic. A lot of people hate Ruby because it's really dynamic. And I think having the type safety of a statically typed language, and then having a macro system where you can sort of add back some of that dynamism, not adding it through the language, but adding it through macros, I think is a really nice compromise, getting all the benefits of a statically typed language with some of the dynamic features that you're used to if you're a Ruby programmer. So it doesn't have, for example, things like respond to and method missing. But it does have respond to, but it doesn't have method missing. It doesn't have a lot of the features that you would expect a statically typed language to have, right? It doesn't have eval, for example. But you can get around that because you have a macro system. It has method overloading. I can show an example of that. It's quite a nice feature. So you can define two methods that do two methods with the same name, but with different arity, and you can define them separately. It's quite nice. As I mentioned earlier, it's self-hosted. So if you learn the language, you can modify the language, read the code of the language. But the thing I really want to talk about for the next few slides is that it has incredible performance, really great performance. And so this is a benchmark. It's not actually a benchmark of Crystal. It's a benchmark of a few other popular programming languages. And the main thing I want to point out on this slide, it's a bit hard to read, but I can read it out. So on the far left is C. And that's C is the fastest language, and it's benchmarked to 1. So if something has a benchmark of 2, that means it's twice as fast as C. Or it's, it's half the speed of C, right? And if it's 50 or something like that, that means it's 50 times slower than C. So C is sort of our baseline. Everything else is sort of scaled in proportion to the C programming language. So one step up from C, you have C++. Then after that, you have Ada. Then you have Rust. Then you have Fortran on Intel chips. Then you have Go. Then you have Java. Then you have Haskell. Then you have Scala. And then there's this big gap, right? After Scala, there's this really big gap, and then there's a whole different category of languages. So this is Erlang. This is Ruby, and specifically MRI. This is PHP, Perl, Python, and JRuby on the far right. And when I look at this, I sort of see two different groups of languages. I see really high performance statically typed languages, right? That's all of these, Scala, Haskell, Java, Go. And then I see a big gap in performance, and then all the dynamically typed languages. So you can say what you want about benchmarks. All benchmarks are flawed. No benchmark is perfect. But I think in general, I think it's fair to say that if you want really great performance, you should use a statically typed language. As a generalization, I think that's true. But the reason we all use dynamically typed languages, the reason why Ruby and PHP and Python are popular is not because they're so fast. The runtime is so fast. It's because they're so fast for writing code. They make you fast, right? They're really fast to deliver a product in. And so if you're writing a web server, you're not going to use C, even though it's going to be 50 or even 100 times faster than some of these languages. You're going to write it in a language like Ruby because it lets you be fast. And so my claim for Crystal is that it's basically the best of both worlds. You get the performance of a statically typed language, but you get to write it in the same way that you write Ruby. You get to churn out code really quickly because it has that nice Ruby-like syntax. And there's some great research about this. Basically, bugs are a constant. So for every 1,000 lines of code you write, there's about 15 bugs in it. And this research has been done and repeated multiple times. There's a nice link on the bottom where you can read more about it. But they did a study of Microsoft, the operating system group, and they found that the average programmer there writes, for every 1,000 lines of code they write, they write between 10 and 20 bugs per 1,000 lines. And those bugs then need to be fixed. So all things being equal, you want to write fewer lines of code, right? If one language lets you do the same task, perform the same program in 1,000 lines of code instead of 10,000 lines of code, you're going to have 100 fewer bugs in that same program, right? So this idea of having a really concise, expressive, powerful language is important, right? And I think Crystal really hits that sweet spot between languages that are statically typed and perform really well for the computer, but have a really nice, concise, powerful syntax, expressive syntax, and let you write fewer lines of code to do the same amount of work. And this is the same benchmarks that you saw on the previous slide. So this is just comparing Ruby with a bunch of different languages. So Ruby compared to C++, these are 10 different benchmarks. Again, take it with a grain of salt, but these are the best possible implementations for 10 different benchmarks, Ruby versus C++. So Ruby loses everything. Ruby is, on all of these 10 examples, Ruby isn't faster on any of the 10. In this case, it's about 3 times slower. In the worst case, it's almost 100 times slower. But, and then in the middle, this is memory. So there's actually some places where Ruby uses less memory. There's some places where Ruby uses more. Let's call that a draw. But in every case except for 1 or 2, Ruby has fewer lines of code to perform that same task. So Ruby, you're getting worse performance, but a lot less code. Let's look at it for Java. Pretty much the same story for Java, right? Ruby is slower, but less code. Okay, what about a functional programming language like Clojure? A lot of people really winning on performance. Ruby versus Rust. So Rust is a new modern programming language. It just hit 1.0. And again, Rust beats Ruby on every benchmark except for one. But Ruby wins on performance, on number of lines of code. Haskell, statically typed system. Again, Ruby is winning, just barely winning on 1 or 2 benchmarks. Yeah, Haskell wins most of the benchmarks. Ruby's still less code than Haskell. So, and maybe I have one more of these. Yeah, so basically the story here is that what if you had a language that had the performance characteristics of a statically typed language, like Haskell or Java or Scala or Clojure is not statically typed, although there are static extensions to Clojure. But if you had the performance of a statically typed language, but with the amount of code, the number of lines of code of Ruby. And for me, that's the opportunity of Crystal. That's sort of the sweet spot that Crystal hits. So this is a benchmark. It's parsing a big JSON file. And here you can see a bunch of different languages ranked in this benchmark. So the best performance for parsing JSON is C++. And the second best of every other language that's benchmarked, faster than Rust, faster than Go, faster than Python, Ruby didn't even make it onto the slide, is Crystal. And there's actually 3 different JSON parsers. There's sort of the default one. They have a schema-based JSON parser and a pull-based. Don't worry too much about the difference there. But you're getting almost C++ level performance in a language that has Ruby-like syntax, really expressive, powerful syntax. And again, you're going faster than Python, Rust, Go, other static languages. So I think that's really impressive, and I'll show some performance benchmarks. Okay, so maybe you're convinced, you want it, how do you get it? So there's really great documentation. If you go to crystallang.org, that's the homepage, and I think you can just click on the docs, it'll take you to that README. If you use a Mac, like I do, and you use Homebrew to manage your packages, you can, it's not built into Homebrew, but you can tap it. So if you say manastech/crystal, then you can just say brew install crystal. You can also just build it from source. Okay, so I just want to give a quick demo of the programming language. How much time do I have? We have time, great. 20 minutes, that should be perfect. Okay, so the first demo, I have a Mandelbrot set here. For those of you who are familiar with fractals and math, that's a Mandelbrot set. And I actually have a Crystal program that generates that Mandelbrot set. So this is mandelbrot.cr. I want syntax highlighting, so I just say set syntax equals Ruby. Oops, you have to spell it correctly. Syntax. Okay, now you get nice syntax highlighting. So this is really readable code, hopefully. Everyone, this should make sense, right? You can look through it and see how it works. It looks just like Ruby code. In fact, it's completely valid Ruby code. So I'm going to execute this program with the Ruby interpreter. So I'm running Ruby. I'll make that bigger so you can see it, even in the back. Cool. Actually, this is going to look really bad because it's going to make a Mandelbrot set. But I'm running Ruby mandelbrot.cr. So it's a Crystal program, but I'm going to run it through the Ruby interpreter just to see what happens, and you'll see it works. Okay. So that just generated a Mandelbrot set. It was, yeah, you can applaud if you think that's cool. Okay, so, and just to prove it, I can run the same thing with Crystal. So I can say crystal mandelbrot.cr. It will do the same thing. Now, Crystal, now that's actually, what Crystal just did is it compiled and then executed the program. So if you just say Crystal and give it some source file, it will compile and then execute the program. I think Go has a similar default. If you're just, if you write a Go program and you say Go in the program name, it will compile and run the program. But let's say you actually want to compile it into an artifact that you can then distribute to other people. The command for that is crystal build Mandelbrot. And if you do that, then you get an executable, so that you get this Mandelbrot binary, right? It's an executable file. And let's just do a benchmark of how fast this Mandelbrot one, I'll do the Ruby one first. So I'll say time Ruby Mandelbrot.cr. Okay, so Ruby was able to generate this Mandelbrot set in about 2/10 of a second, something like that. So you could do 5 of these per second. Let's see how fast the Crystal one is. Okay, so 0.2. So it's basically 10 times faster, just the exact same code. I wrote the same code. I didn't do anything differently. I just ran it through a different interpreter, right? It's way faster in the Crystal implementation. And just to show that I didn't get lucky, I'll run it a few more times, right? So here's the Ruby one. So yeah, 0.19, 0.17, 0.18, pretty consistent. Here's the Crystal one. 0.01, 0.00, 0.00. So the idea is it's compiled, right? Like you can basically compile this program just into its output. If you have a smart enough compiler, you can just have this be like a bunch of put statements. You don't actually have to do the math to generate the fractal, right? That's the big benefit of having a compiler, having a compiled language. It's easier to distribute and you can do all these compile time optimizations. Yeah, so the question was, can I compile my Rails app? The answer is no. So yeah, it doesn't have the same gem ecosystem that Ruby does, right? Crystal doesn't have this. So there is no Rails for Crystal, but there's a Sinatra clone called Frank. So you can write web apps in it. That's a good question. So yeah, most of us are Ruby programmers. We're interested in writing web apps. So I guess the next demo I'll do is of an HTTP server. Okay. So I'll make this bigger just so everyone can see. So I'm just saying require HTTP/server. This is from the standard library. And the syntax is quite nice. I'll actually make it even more Ruby-like. This probably looks a bit weird to you, but this is also completely valid. So I'm just saying start a server on port 8080, and then, yeah, Crystal has blocks, right? So it's yielding a request to the block. And in this case, all I'm going to do is I'm just going to return HTTP 200 and hello world, right? So it's just a plain text server. Yeah, and then I just output listening on the port number and server.listen. So let's run that. Crystal build HTTP server.cr /HTTP server. Okay, and just to sort of prove that it does what it says it does, I can curl that, and whoa. That's maybe, yeah, but that's surprising actually. Okay, 8081. Crystal build HTTP server, run the HTTP server, curl 8081. Hello world, that looks a lot better. Apparently, I'm already running Nginx on port 8080. Who knew? And you can, request it with the headers, and it's, sets the right headers. It's an HTTP request. Nothing fancy, but pretty good. Okay, and you can do the same thing in Ruby. So if you say this sort of magic command, it does basically the same thing, right? So let's run this one on port 9090. This is our Ruby HTTP server, and I guess I can curl it from another window. I'll make this one bigger. Curl. What did I say? 9090? Yeah. So it's like a normal, I don't know, this is like the default WebBrick response. Yeah. Okay. So, oh, that's interesting. So it's actually serving up, it looks like it's actually serving up that directory as files, right? It's just like a basic file server. Okay. So let's say I want to benchmark these. So I can just run Apache bench. So okay, let's actually do the Ruby one first. So here's Apache bench, and let's be nice to Ruby. So let's just do 1,000 requests with a concurrency of 100. So this is going to be 1,000 requests, and we're sending 100 at a time. So the first 100 all go at once, and then once we get 100 back, we send 100 more until we have 1,000. So let's see how long it takes for Ruby to serve up 1,000 requests with sort of a parallelism concurrency of 100. Okay, there we go. Great. So you can see all the different stats, right? So the mean request time is this 249 milliseconds it looks like, or median I mean, and then this is the longest one was about half a second. Okay, so not so bad. Could be better, could be worse. Let's do the same thing for Crystal. So I'm just going to run my HTTP server and change this from port 9090 to 8081, and we're done. Yeah, question. Why don't I pass keep alive? Because I want to show how it's handling 100 separate connections. I don't want to reuse the same connection over and over again. I want to open 100 sockets because that's what I'm benchmarking. Yep. Okay, so this is the Crystal version. The median time was 10 milliseconds. The longest was 81. So the longest request in Crystal is faster than the median for the default Ruby web server. I think that's quite impressive. Okay, I'll show a few more examples. What can I show? So maybe some things around, okay, well I can show this. So this is strings. I'll just make a new file, strings.cr. So I can pretty print a.class versus a.class. So this, I mentioned this earlier, but this was in Bojdar's talk about sort of, in Ruby, we have these sort of bike shedding discussions about single strings, single quoted strings versus double quoted strings. In Crystal, you never have these discussions because they're actually two different things, right? So if I run this program, I'm not going to build it first, I'm just going to run it. So this is called strings.cr. Sorry, what was that? Question? No. Okay. So if you run it, it's you see the class of the single quoted A is a character. The class of the double quoted A is a string. Here's another sort of example of that. So if you have an array, I can just say, yeah, whatever, A equals 1, 2, 3, and maybe I want to map that to x squared or something like that. Yeah. Okay. And then I can pretty print A. Again, pretty print is part of the standard library, another great part of the standard library. Wish it was part of Ruby's. Maybe, is it now? No, it's not. I don't think so. Okay, A is 149. What about these crazy aliases, right? Can I say collect? No, I get a syntax error, right? But so Ruby doesn't have all these crazy, or sorry, Crystal doesn't have all these crazy aliases for things that Ruby does. It has more the Python philosophy of there should be one way to do one thing. And I think that makes the language a lot easier to learn. It makes the code a lot easier to read, right? You don't have to learn that map and collect are two different keywords that do the same thing. It has aliases, right? So if you like typing collect in your programs, you can just create an alias for that. No problem. Right? But the language, the way it comes built in, it has one way of doing something, and I think that makes it quite nice. And if you look at this error, it's a really beautiful error, right? This is sort of the LLVM for people who've used LLVM before. This is the LLVM error output format, and it sort of gives you this nice arrow showing you exactly where the problem was, and a pretty good description of what the problem was. Strings.cr on line 1, undefined method collect for array of int32, right? So this is a statically typed array. Let's spend some time, and keep in mind, Crystal figured out that it was an array of type int32 automatically. Let's play around with that a bit. So what if I say A equals array of 1, 2, 3, and then I want to say, let's push 4 onto that and pretty print A. Hopefully everyone believes that that will print 1, 2, 3, 4. What if I try to put the string A onto it? This will fail, right? So the idea is that, and again, you get quite a nice error and the little arrow showing you exactly where it happened. Strings.cr on line 5, no overload matches the push operator for an array of type int32 with the type strings. But I can fix that. So what I can do is I can say this is an array of type int32 or string, right? So this is the union typing feature I was talking about earlier. So you don't need, right, there's type inference, and let's just say, for example, I'm just going to comment this out actually. There's type inference. Let's just say this started off initially as a mixed integer and string type array. Then this is no problem. All of a sudden this code works, right? I can say a.class, and it will tell me, right, so it will push A onto the end of it, and it'll tell me that A is an array of the union type string and int32. But if I don't initialize it that way, and I want to be able to push strings onto it later, that's fine. I can just declare that explicitly, right? It couldn't infer that from our program, so you have to be explicit about it. Okay, and that works too. Era has a question in the back. Yes. Yes. The question was, can you declare the array without the data? So here's an empty array. and I'm saying explicitly that it's of type int or string, it will let me push ints and strings to it, so this array should contain 4 and the string a, and it does. But let's say I try to push a float onto it, for example. Doesn't work. Sorry, okay. So that fails for a different reason, but now it will fail for the reason I wanted it to. Oops, that's wrong tab. Okay, now it fails for the reason. And again, it's quite nice. It says no overload matches for the object array of types string or union int32, the push operator with type float64. Yeah.
Can you push integers to the float array?
No, you can't push integers to a float array. Yeah, but I mean you can if you explicitly declare it as so. And okay, so let's do some other. So like let's see how this works with methods, for example. I'm just going to stay in this same file. So here I'm defining a method called plus. It takes 2 arguments, a and b, and I'm just going to return a plus b, right? So I can pretty print plus for 1 and 2, and that should give me 3, and I can pretty print plus for foo and bar, and it will give me foo bar, right? That all works completely dynamically. But what I could also do is I could say this needs to be a string explicitly, right? And if I do that, then this doesn't compile, right? You get a compile time error, right? What are some of the other things? The method overloading. So yeah, I could fix this. One way to fix this problem is by doing this. I could say this is with an int32 and b. Right, so I'm going to dynamically dispatch based on the type, and now this works again. Right, so this is the one that's doing plus for, the first one does it when the first argument is a string, and the second one does it when the first argument is an integer. And obviously you could do it for both arguments. Can you add different types? Yeah, you can define, oh yeah, sure, great. So, yeah, like, I mean, I should also say it's quite smart. So if you have this plus method and that like delegates to some other method, it will do the type inference across methods and across classes. Yeah, it's really nice global type inference. So at compile time, it goes through all your types. Your question was, can you define it, do it for your own types? Sure. So give me a type. User, okay, and what does a user have? A nickname, okay, so Ruby doesn't have attr readers and attr writers. It has getters and setters. It's the same thing, it's just shorter and a little bit, I don't know, I think it is more explanatory. Okay, so I can say getter nickname, something like that. Okay, so what do we want to do? We want to have the plus method is going to take, I can just make a new one. So this is plus, and it takes a user A and a user B. Oops, that says Uber. Okay, and what it will do is it will call a.nickname plus b.nickname, right? That's our implementation. Nickname, thank you. Okay, so let's call that one. Okay, so let's just have a user A, user.new, nickname is Erik, and yeah, is there another nickname that somebody, what is it? Erik1, very creative group here. Is there a default constructor for user? No, there's not. Thank you. This is a cool feature. Boom. Name, nickname. You can have instance variables like that, and then you're done, right? So you just pass that in, it gets assigned. You don't need to do this. This is not a feature in Ruby. Cool feature in Crystal. So this should say, because I'm using, right, exactly. So you can use keyword arguments. Crystal has that, but in this case, that's not how I define my function. And yeah, so I have 3 different plus methods, one that handles integers, one that handles strings, one that handles users. It all works.
What if you don't specify the types? Is it actually compiled every possible combination of
Yeah, good question.
Like C++ or like Java generic, so it eliminates the types and just do it on the runtime?
I'm not going to answer that question directly. Ask it again in a second, but it made me think of something else cool that I want to show. So there's this crystal. Why did that? Oh no! Please no. What happened? Okay, that's embarrassing. Yeah, maybe I need to recompile Crystal. Okay, I won't show that feature. Ask your question again. Sorry.
What if you declare a function without the types and call it with different types? Does it actually handles the conversion?
Yes.
Or it compiles
No, it compiles it. So yeah.
It generates a different function for every combination of types.
Yes, exactly. No, it doesn't. It creates a union type. So the question was, going back to this version, what if you have a function that doesn't specify type, and you call it with two different types of arguments? In the first case, I'm calling plus with integers. In 32s, the second time I'm calling it with strings. What does it do? Does it create two different functions, one that takes integers and one that takes strings? It could, in theory, as an optimization, but I'm pretty sure what it does is it actually creates a union type. So this method, the plus method, is guaranteed to return either a string or int, right? It's the union type of int32 union string. So, yeah, and then if you try like taking the return value of that and passing it into something that doesn't that isn't typed correctly, that doesn't take a int or that doesn't know how to handle an int or string, then it will blow up at compile time. Bunch of questions in the back.
Sorry, Erik, maybe you can make a conclusion and we have a question sections quickly, okay?
I'm happy, like, this is just a demo, so I'm like pretty happy to just like take questions as they come and show some code. How much time do I have?
5 minutes.
Okay, yeah.
Okay. Sorry guys.
Sorry, can I show like a block or something?
Any kind. Can you show any kind of anonymous function?
No. So Crystal has blocks, but it doesn't have procs, which I think was another one of Bozhidar's points in his talk. So I'm calling that a feature, not a bug. Yeah.
What about internal implementation of collections? So when you define the array of integers, what it's like internally, and does the performance downgrades when you have an array of union type of integer and string?
Yeah, great question. So when you have a typed array and the type is homogeneous, and especially when it's a primitive type like integer, you can make all sorts of compile time optimizations when you have a single typed array, right? So as an example of that, let's say you have an array of 1,000,000 integers and you want to access the index of the 547,322nd. Right? The way to do that, if you know that every single thing is of the same type, everything is a 32-bit integer, what you can do is you can just multiply whatever number I said, 532,474, whatever I said, times the width of a 32-bit integer, and jump to that point in memory. Right? You don't have to actually traverse the array to get to that middle point. So you can have constant time lookup for single typed arrays. You can't take that compile time benefit if you have a union typed array, unless the union types are happen to be the same size or something like that.
So what is the memory type of Crystal? Is it just a heap-based memory management, or you can choose between stack-based and heap-based object allocation?
I'm pretty sure it's heap-based, but that's a better question for the mailing list. Yeah.
Okay, thanks.
I actually have two questions.
Okay.
First, can you please tell us how production-ready Crystal is? And the second one, can you please like throw an exception and show us how exception stack trace look like?
Yeah. So how production ready is it? I know Monastech, the company that built it, they're a consulting company. They built it for their own use in their consulting projects, and I'm pretty sure they've deployed it for their clients, so they're accepting money and deploying Crystal. That said, like, I just hit a compile error, so your mileage may vary, but I would say, like, if you like I will, after this presentation, report that error, and I think it will be fixed within a day. That's been my experience with it. So it's at the very early stage of a language. It's not yet 1.0. If you're doing something that's really critical infrastructure, I wouldn't ship it necessarily, but what I've found it to be really great for is command line interfaces, for example. So with Ruby, if you ship a CLI, there's all these dependencies. People need to install Ruby first, which maybe they don't want to do or don't know how to do. And then it's just slow, right? Like the startup time of Ruby and the parse time of parsing through all the dependent gems and things like that. Like even if you're just doing the help command, have you ever like done something like this? Like if you just say like time rails -- help or whatever. Okay, so it took almost a second just to get this like very static help page. And it shouldn't take, like, it took, 3/4 of a second. Why does that take 3/4 of a second? So if you're shipping a command line interface, I think Crystal's a really good use case for that. And if there's any errors, you'll get them at compile time, right? It's not like you're gonna ship that binary and then it's a binary, right? So if it compiles, the types are right, maybe it has bugs, but if it works for you, then it's production ready. So that's a really good use case. You also asked a question about exceptions.
Exceptions, yeah.
But I'm not sure I have time to, there's like other questions. Let's talk about that after. Is that okay?
What is about pattern matching? Does it support it?
Sorry, say it again.
Does Crystal support pattern matching like in F#?
Pattern matching?
Pattern matching, yeah.
No, not really. Like there's not in the way that Elixir or Lisps do, or Haskell would.
Yes, thank you.
Yeah, as far as I know, that's not. Just because there's no specific syntax for it. Like that said, if there's like, you can have like a case statement or something like that, so you can get close, but.
Is the main sense of Crystal like SMJS to have the same syntax as the Ruby? And pattern matching couldn't be
that's one way to think about it, I guess.
right.
Yeah.
Okay, I got
but
it.
it's not actually doing pattern matching the way you would in a language like Elixir or Lang. Yeah.
We are talking about parallelism.
Yeah. So the question was, I'll just repeat it because you didn't have a mic, was about parallelism and how fast that is. It has basically the same threading model and threading primitives as Ruby. So not a great story, to be honest, but it's no worse than Ruby. And it's going to be, no, it has channels. Sorry, I should say this is like in the most recent release. You should look at the website. So they just came out with sort of Go style channels. So this is in the language, this is a primitive. And it has threads, it has fibers, so it has like everything that you have in Ruby plus channels. Julian, yeah.
What architectures does it support? I'm assuming maybe because of LLVM it can run on ARM, I'm hoping anyway.
It can run on ARM. I would expect it to, but I'm not sure. I've never tried running it on ARM. But yeah, maybe you could control some robots with it. That would be cool. Maybe we can hack on that later.
Hello. Does Crystal support multi-threading and multi-processing?
Yeah, so that was the question. So it does, like it has the same threading primitives as Ruby, plus it has channels. And the channels are quite new. I think they were just added in the most recent release, 0.7. But if you join the mailing list, there's a lot of discussion there. So like if there's like some threading model that you really think Crystal should have, you can like ask for it and maybe get it, or just build it yourself.
Yeah, but by the way, what about the gems?
What are the gems? Yeah, okay.
Yeah.
So there are no gems because everything needs to be compiled at compile time, right? You need all the code there when you're building the package. So there's something called a package file, and there's a command, so I think it's Crystal PKG or something like that. Crystal deps, and that will basically, I think it's called, I can show an example. So in this Twitter example, one more. Yeah, so I'm building a command line interface for Twitter. I previously did that in Ruby, and now I'm in the process of porting it to Crystal. So they have something that is called a project file. Did I say it was called a package file? It's called a project file. and it looks quite similar to a gem file. Basically, you can just specify dependencies as GitHub repos. So I think this is actually quite similar to the way Go handles dependencies. I'm not such an expert in that, but I think it looks more or less like this. And then you can run this crystal deps command, and it will resolve those dependencies. So it resolves them into this libs directory. So I can blow that away, and you can sort of see it do, yeah, now there's a libs directory, and it imported, yeah, okay, it aliases that to deps. Yeah, it just pulls it in from GitHub.
So one more question.
Yeah.
I'm a big fan of meta-programming in a way. So, and I also agree with you that the more code you write, the bigger the chances that there will be more bugs. And what I wanted to ask you, if you ever have thought about code generation, like writing code that generates code that you can run then.
Yeah,
other.
It's not a dynamic programming language. You can't do all the metaprogramming in Ruby that you're used to, but there's a macro system. And so, for example, before I was showing you the getter method, the way the getter method works is it's implemented as a macro. So, it doesn't show that. Okay. But you can see how macros work. So this is what a macro looks like. So if you want to sort of dynamically define a method, it sort of uses this mustachy, handlebar, curly brace template syntax for defining macros. So if you want to do metaprogramming, this is your tool for doing that.
Okay, I think we end. If you have a question, you ask Erik after presentation. Okay, thank you, Erik. Great speech. Я напоминаю две вещи. Первое, у нас в холле появились ребята-массажисты в зеленых футболках. Вот, если хотите массаж, пожалуйста, обращайтесь к ним. Да, массаж, да. И второй момент, мы разыгрываем после следующих, в конце сегодняшнего дня, мы с помощью нашего Ruby спонсор, наш Data Art, разыгрывает призы среди всех тех, кто заполнил анкеты. Поэтому если кто не заполнил, может заполнить. И в конце будут разыграны призы. Все, ждем вас тут через полчаса, чуть меньше.